Hi. So today we're doing lesson 8 and 9. Lesson 8 is the tangent ratio. So this is, you would have encountered tan during, in math 10. You would have encountered a little bit of trigonometry in addition to your Pythagorean theorem. So first thing we're going to do is we're going to talk about what sides are what. Now the tangent ratio, if we have a triangle, a right angle triangle, so one of the angles is a right angle, that's where that little square is, right? We have three sides. If we're looking from this angle here, we can label all the sides in relation to that angle. Now, we know the big one is the hypotenuse. So the big one, the one opposite the right angle is the hypotenuse. Always is, doesn't matter which angle we're looking from. So we have two other sides. We have one right next door to our angle and one across from it. So looking from this angle, the one right next door is called our adjacent angle. The one across it or opposite is the opposite angle. So once you find the angle you're looking from, I like to actually draw these little lines in. You can eliminate the hypotenuse and then it's labeling the opposite and adjacent. Now, just a note, if you're looking from the other angle, it's going to change things. So say we're looking from this angle up here. Well, the hypotenuse is always the biggest one across, right? But now the one right next door is the adjacent, and the one across is the opposite. Now, if we were doing this class in person, I have a cool little activity where we cut out paper and we make our own little triangles. Sadly, I can't do that with you. So you might want to draw this picture somewhere so you have it as a reference, okay? Now, let's now use this and we'll label these triangles. So, we're always looking from the angle indicated. So here we're looking for, from 37, it wants us to label the opposite, adjacent, and hypotenuse. So we're just going to label op, adjacent, and hypotenuse so that we save a little time and space. Okay, so from 37, well, first let's label our hypotenuse. It's always the big one, right? So we'll label that, get her done. It's the one opposite the square root. With 37, the one right next door is the adjacent, and the one opposite is opposite. Okay? Now I'd like you all, you can pause the video, try the next one, and then check and see if you got it right. Okay, you're back. So, again, here, first thing we can find is the hypotenuse. We're looking from angle 35. So that's our perspective. Right next door is the adjacent, and across is the opposite. Okay? Hopefully we got that right. Try the next one, and when you're back, you'll see if you're right or not. Now you can't see those pictures that we already drew, so we'll have to remember. So, across from the square is our hypotenuse. We know where to find that because we've been finding it for the Pythagorean theorem for a while. We're looking from this angle here. Right next door is adjacent, and across is opposite. Okay? And then we have one right here. Got a stray red mark there. Let's try this one if you want to try it on your own first, and then come back. So, we're looking from this angle here, angle theta. We use this symbol theta a lot when we're looking for an angle, so it'll come up. So, across from the square is the hypotenuse. Right next door to our angle is the adjacent, and across is our opposite. Okay. So hopefully that helps you identify where those are. Now, we've done that work. Now we're going to calculate the tan ratio. Now up here in the original, no, it says the tan is opposite over adjacent, where A is the angle. So I'm just going to make a note of that. Tan equals opposite over adjacent, and that's the sides. So for the first one, it says tan of 37. So we have our blue triangle here, that's A. So our opposite is 6, and our adjacent is 8. So if we're doing our tan ratio, it's, what did we say? Oops, I already forgot, just scrolling. Opposite is 6, adjacent is 8. So it's opposite over adjacent, so it's 6 over 8. Now I can divide that, and when I divide it, I get 0.75. Okay, so it's a ratio, but we're going to put it in decimal form. Now looking at the second triangle, our opposite, let's circle these, is 8, and our adjacent is 11. So 8 over 11. Okay, so 8 over 11, and when we divide, I get 0.727. Okay, now the next two have x's in them. That's okay. So let's find them. For C, my opposite is 10 and my adjacent is x. So we can still put that in the ratio. We just aren't going to be able to divide. So it's going to be 10 over x. And for D, my adjacent is 15 and my opposite is x. I always recommend going and doing that labeling about opposite and adjacent before you start answering your questions, because then it'll help you when you're filling in questions. So if I'm looking from theta, my opposite is x and my adjacent is 15. Now, there's x's in those. Later we're going to figure out how to use them. Okay? Now, we can also calculate the tan ratio of a known angle using the calculator button on our tan button on our calculator. Okay, so so you all have on your calculator, you have a button that says tan. For most of your calculators, your procedure is going to be, you put 20 in and then you press the tan button, and it will give you your number. If you have a graphing calculator, you're probably going to have to put tan first, then 20, and then the equals button, and it'll give you your answer. Okay? So it depends on your calculator which one's going to work. I'm going to do it on mine, and we'll talk a little bit about what setting you have to have your calculator on. You have to have it on degrees. If it's not in degrees, you'll get the wrong answer. Most calculators are going to be in degrees, but sometimes they're not. So, sorry, I did the wrong button there. So we're doing 20 degrees, and we want to know the tan. So for your scientific calculators, put in 20 and then hit the tan button, and you should get 0.3639. We're only doing to 4 decimal places. Okay, and this actually rounds up, so it would be 3.640, but I'll cut you some slack. Okay, if you didn't get that, then you need to find a button called DRG, or on a graphing calculator you need to press the mode button and you need to put it into degrees. DRG, you're probably in rads or gradients, so you just press it till you get the degrees. If you didn't get this answer, just let me know and I can help you through getting your calculator in the right mode. Okay. The next one, tan of 45. So you put 45 in and hit the tan button and you get 1. Just 1. You could write 1.0 if you want, but it's just 1. Again, if you don't get that answer, you're probably not in the right mode, and let me know and I'll help you fix it. 86, so we want to know the tan of 86. So you put 86, hit your tan, you're going to get 14.3006. So it's actually 14.3007 because it rounds, but I'll cut you slack. Tan of 1.88 degrees. So 1.88, hit your tan button, and you get 0.3282. Okay? Try the last two on your own, and then we'll check and see if we're getting them right. When you're back from checking them, good. So for tan of 9 degrees, I get 0.158. It actually will round, though, up to 1584. Either one of those I would give you. Tan of 39, we get 0.8097, but it actually rounds up to 0.80. Oh, sorry. No, 98. So either one of those I would give you. It's 4 decimal places, so we're pretty good. Okay. Now it's time to do some practice. So you're going to practice some labeling, and then you're going to practice finding some decimal places of tan. All right.